Okay, this is dilation task number 2, an answer key with explanation. So you should have already done the dilation task, or at least attempted it, on page 28. So what I hope you notice first is that you have two rectangles. Your original is your pre-image, and then it's been dilated or reduced to this smaller rectangle. For this activity, they're asking you, or they asked you, to find the scale factor, the perimeter of both shapes, and then to see how the perimeter was affected by that dilation, and then the area of both figures, and then to figure out what the how the area was affected by the dilation as well. Let's go ahead and go over those first 7 problems now. So the first thing you should have noted is that the measure of each side of each rectangle, so this side length was 9, this side length 6, and then of our image 2 and 3. To find the scale factor, you had to compare the corresponding sides. So if this length was 9 and it was reduced to 3, it was reduced by 1/3. The same here, from 6 to 2, it was reduced by 1/3. That's why we can say our scale factor is 1/3. Now when they ask me for the perimeter, all you're going to do for the original figure is add up 9 and 6 and 9 and 6, and you should have gotten that the perimeter was 30 units. Finally, the perimeter of our smaller image is 3 and 2 and 3 and 2, to which you should have added up to 10 units. Now they ask, how was the perimeter affected by this dilation? Well, what is the effect of 30 to 10? How does that happen? I think if we think about what the scale factor did to the sides, if it's reducing each of these sides by 1/3, it effectively reduces the entire perimeter also by 1/3. And we can prove that by saying that the original 30 perimeter, if I multiply that by 1/3, I would find that 1/3 of the original perimeter is what my new perimeter is, 10 units. Now we're going to do the same thing for the area. This time the area is going to be the length times the width, and the length times the width. So here I find that the area of the original figure was 54 units squared, and the area of the diluted figure was 6 units squared. Now, finding how the area was affected by the dilation is a little bit more challenging. In this case, we're looking at how did 54 become 6? This one's not as obvious. I'm going to scroll down a little bit. I think we're going to need some space here. Now, I think you're probably saying, well, divided by 9, right? So maybe you're noticing that 54, and let's just go ahead and formalize. Instead of saying dividing by 9, let's say multiplied by 1/9. That gives me 6. And I agree. 54 divided by 9 does give me 6. But what does that have to do with the scale factor? So let's think about the math we did, okay? Let's go backwards here. Let me pull up a green pen here. Okay, when we found the area of the original figure, we said it was 9 times 6, and we got 54. So now let's look at our smaller dilated figure. How did we find the area of the image? Well, that was 3 times 2, right? Or, go with me on this, 9 times 1/3. Okay, that's the 3, right? And then 2, or 6 times 1/3. Oh, hold on, I know maybe you don't believe me here. 9 times 1/3 is what? 3. Okay, and how about 6 times 1/3? 2. And what is 3 times 2? 6, or 6. So when I look at, let me squinch this down a little bit. When I look at this 1/9, excuse me, sorry about that. when I look at this 1/9, I know exactly where it came from. The 1/9 came from my scale factor twice. 1/3 times 1/3. So how was it affected? It was the scale factor times itself, or k squared. So for your last problems, questions 8 and 9, they ask you to consider two rectangles that are similar. Rectangle ABCD with a length of 5 and a width of 10, and a rectangle ABCD that's been dilated with a scale factor of 4. Now, since it's greater than 1, I knew that it was going to be enlarged, and a scale factor of 4 means that my k value is 4. Well, they asked how's the area affected and how is the perimeter affected. Now, based on what we concluded from our dilation test before in questions 1 through 7, I was able to tell that this side length would be 4 times longer and this side length would be 4 times longer. But more importantly, I can find the perimeter and area of this rectangle without doing any calculations here. I could have done it without an image at all. What I know is that if I can find the perimeter and area of my original figure, there's a relationship between that and the perimeter and area of the image. So here's what I know. If I want to find the perimeter of the image, it'll be the scale factor times the perimeter of the original. So in this case, 4 times 30, or 120 inches. And we can verify that. 20 plus 40 plus 20 plus 40 is 120 inches. The area is 4 times 4, or the scale factor squared, times the area of the original figure. Or in this case, 16 times 50, which is 800 inches squared. And that makes sense because if you multiply 20 times 40, you would get 800. Just as a side note here, I hope that some of you sticklers for detail out there noticed that this length was smaller visually than this one, but I labeled it 10 inches and 5 inches. Same here, 40 inches and 20 inches. Let that be a lesson to everyone that our drawings are never drawn to scale, and you can never trust the picture.